Earth's atmosphere is composed of gases, dust, and molecules that help shield us from harmful radiation coming from the sun. The five major and most abundant gases in the atmosphere are nitrogen, oxygen, water vapor, argon, and carbon dioxide. Nitrogen makes up 78%, oxygen makes up 20.95%, water vapor makes up around 0 to 4%, argon makes up 0.93%, and carbon dioxide makes up 0.036% of the atmosphere. Despite the small amounts of carbon dioxide and H2O in the atmosphere, they need to stay in balance with the other gases or global warming will occur. Carbon dioxide and H2O are more complex than the other gases, meaning that their structures can absorb more heat. Specifically, they absorb infrared radiation, re-emit it, and even transfer it to other carbon dioxide and water vapor gases. This process of absorption and re-emitting infrared radiation into the atmosphere can cause an increase in global temperatures known as global warming. Because they cause global warming, they are classified as greenhouse gases. Both oxygen gas and nitrogen gas are composed of two atoms, while carbon dioxide and H2O are composed of three atoms. Molecules that are made up of three or more atoms are held together loosely enough that they vibrate when they absorb infrared radiation. Eventually, the vibrating molecules release radiation, warming the Earth's surface. Since oxygen gas and nitrogen gas molecules are composed of two atoms, molecules are bound together tightly and unable to vibrate, so they cannot absorb heat and contribute to this effect.
So, for a molecule to absorb energy, shifting charges for each of these mixed molecules have to occur at a certain frequency. If their frequency happens to match that of a radiant energy, such as infrared energy, that molecule with its charges already oscillating at that frequency will absorb the energy. In much the same way that someone pushing a swing with the right frequency adds to the motion of the object. Therefore, the atoms with the most concentration, but not too much concentration, will be the best at absorbing energy. So out of CO2, CH4, and CFCs, like CFCl3F and CCl2F2, I've concluded that CFCs have the greatest concentration of all of them and are the best at absorbing the most infrared energy. Human activities contribute to climate change by causing changes in Earth's atmosphere and the amounts of greenhouse gases, aerosols, which are small particles, and cloudiness. The largest known contribution comes from burning up fossil fuels, which releases carbon dioxide gas to the atmosphere. Concentration or abundance is the amount of particulate gas in the air. Larger emissions of greenhouse gases lead to higher concentration in the atmosphere. Greenhouse gas concentrations are measured in parts per million, per billion, and even parts per trillion. 1 part per million is equivalent to 1 drop of water diluted in about 13 gallons of liquid, roughly the fuel tank of a compact car. So these models are the 5 major and most abundant gases in our atmosphere. Here we have nitrogen, N2, argon, Ar2. We would have carbon dioxide, CO2, water vapor would be H2O, and oxygen, which would be O3. Nitrogen makes up most of our atmosphere, with oxygen coming with a second with 20.95, while water vapor makes around 4%, and argon makes very little, with around 0.036%.